All right, so this is our first lab in our analyzers course here in IET 225. And I just kind of wanted to go over a few things here because we are doing this remotely. The first thing that we want to make sure is we have access to these documents that we're going to be using here: safe work practices, safe job procedures, formal hazard assessment and control template, and a site-specific hazard assessment control template. Because we're going to be filling out some of these documents. The procedure down here, there's 3 jobs that we're going to review, and I'm gonna actually give a review of some of the equipment here in our lab that we're using to kind of simulate the job that we're going to be performing. The first one here is replacement of calibration gas. So this is a routine replacement, and that kind of gives us a hint as to what type of assessment we should be using to perform this. Since it's routine, that means it's reoccurring. We're replacing a calibration gas cylinder on a gas analyzer, and the bottle weighs about 100 pounds. It contains natural gas, which is flammable. So this is heavy, it's flammable, and it's at a pressure of 500 psi. So that's high pressure. So right there, that gives us 3 hazards that we have to deal with. And I'll just take you over to our analyzer right now just to kind of point out some of this stuff so you can see the actual. Here in front of us, this is our gas chromatograph. We'll be seeing it in our second analyzers course. Over here, right here in front of us is a high pressure gas cylinder. And if we look here, it has, actually it's got more than 500 psi, it's up to 1500 psi. So it's high pressure. This is flammable, it's a natural gas mixture, so it will burn. And the bottle weighs approximately 100 pounds is what we've sized it up to be. So those are our 3 hazards. We have, it's flammable, it's heavy, and we've got high pressure. So in our hazard assessment that we're going to be doing, whether it's the formal or the site specific, I'm going to let you decide based on the information given. We need to identify those hazards and decide how we are going to control them, whether we're going to eliminate them, whether we're going to use engineering, we're going to add something physically to prevent these hazards from occurring, or we are going to administratively do something, write out a procedure, like a safe job procedure on how to change out this bottle, or also the PPE that we might wear. So those are some examples of controls that we would use for this particular job. So the next job here is the removal of a water flow meter. It says the technologist is removing a saltwater flow meter on the 3-phase separator to take to the repair shop to troubleshoot inaccurate readings. There is an electric pump that feeds salt water through the meter. Line pressure is at 50 psi. So they've identified a few things here that we need to try to pull some hazards out of. So we'll go over and have a look at our 3-phase separator and the water meter that we're removing to troubleshoot those inaccurate readings. This is our 3-phase separator trainer here at the college. It separates oil, water, and air. Those are the 3 products flowing in and the 3 phases that get separated. Over here is our water tank with that water meter that's reading inaccurately that we want to remove and take in for service. So our pump here pumps the water off the bottom of the tank, and the line pressure is going to get up to 50 psi. So we want to make sure that we aren't pumping and that the pump can't turn on when we go to pull this meter out, because for one, we're going to get sprayed probably. If we get sprayed in the face with salt water, all kinds of hazards. We could slip, trip. So we've got that pressure. We want to make sure the pump is shut off. The system is de-energized. So pressure in our system. The other hazard is the electrical part here. We could get electrocuted. This is salt water, highly conductive. So electricity, second hazard. And the third hazard here, you can see we're going to be wrenching on these bolts here and pulling the meter out. And there's pinch points here. So we want to just make sure that we're aware. We don't have our fingers in the flanges and stuff like that when we're trying to pull the meter out, because it would pinch our fingers. So that would be our third hazard. So we need to come up with some controls on how we are going to manage that. The one control, it would be a lockout tagout. And the main power feed over here is over here in the cabinet. I'm going to take you around there and just show you how we would lock and tag out our pump down here to help eliminate that hazard for electricity and the pump turning. So I just wanted to show you over here is the electrical cabinet. The power feed comes over to our pump here from that electrical cabinet, and I'm just going to show you on the back side how we would tag and lock out our so right here, this is the back side of our electrical cabinet here. I'm just going to open open this up, right down here is the 3-phase power distribution here. This is going to feed the motor. Some of the main feed comes in over here, exits over here, comes up through some of this conduit here, and then it goes down. This is the motor contactor right here. So when our control system tells the motor to turn on, this is like the switch that allows power to flow out to our motor. So there's fuses right here. And it's actually these bottom 3 fuses right here that we would pop out. We would pop those out, and then we could probably leave them down here in the cabinet when we're finished. But what we want to do, the way that we would lock this out, since there's no locking mechanism here on the fuses, we would then shut the cabinet, you can see, and shut the cabinet, and there's a lock right here. We can actually lock it out and put some sort of a tag here identifying who locked it out and where to find the key. All right, so our third and last job for review is the replacement of a corroded control valve. Technologist is removing a control valve that unexpectedly corroded and started leaking, and is installing a new control valve that is more chemically resistant to the process. The control valve weighs 80 pounds and is supplied with compressed air at 80 psi. All right, so this is our control valve here with the corroded trim. You can see right here as well, it's a flange connection. So if we are putting this back into service, we want to make sure that we are aware that we don't want to be putting our fingers in here and getting them pinched when you're lifting something into place. Sometimes you forget and get your fingers where they shouldn't be. So we'd have pinch points here as well. It's 80 pounds, so we want to use proper lifting techniques. So pinch points, hazard 1. Second hazard would be the lifting of the valve, and the third hazard is the supply pressure for this valve is at 80 psi. So right here, actually, you can see the gauge is at 80 psi, and there's a valve here that we'd want to shut that off and bleed the air. You can see this is the main supply in, comes into the regulator, goes over to this tubing, and then down and over to our valve right here on the back side. So we want to make sure that when we are taking this out of service that we are slowly taking the nuts off to make sure that all pressure is relieved, and kind of wiggling the tubing around, and that kind of ensures that there's no pressure there. So there, we have the 80 psi, we have pinch points again, and the heavy lifting. That we definitely don't want to forget about actually is the process here flowing in. It's our air coming from our blower over in our mechanical room. If we were pulling this valve out, we want to make sure that the blower couldn't automatically turn on. So we want to disconnect that. So this, you can see the piping runs up and over into our mechanical room over here. So I'll just take you over there and just show you the disconnect that we want to lock and tag out to ensure that someone can. All right, so I'm just over here in our mechanical room. This is the blower right here, and you can see there's a disconnect switch right here. So we would need to close the disconnect switch and then lock it out with a lockout tag out, so then the blower could not be energized when we're removing that valve. All right, so here's an example that I completed one of the 3. You'll complete the other 2. Removal of flow water meter. So I chose that example to demonstrate here the site-specific hazard assessment. Company name, Red Deer College, work to be done. This is lab 1 in the IET 225 course. We're doing it at the instrument lab, so all of this will be the same on yours. Muster point will be the same. It's in the east parking lot out of the lab. We're doing this remotely, so but yes, since you won't be at the lab, I'm giving you all this information. And then August 27th, 2020, put the date in that you did this, and identify all the hazards that we pointed out in the video here earlier on. And then I want you to come up with ways to eliminate or control them. I mean, actually just control them, because we can't eliminate them. We're still going to be performing the task. So administrative, you can see I identified the type of control. It's an admin control. Follow the lockout tagout. We're going to lockout tag out the pump according to the tagging and lockout safe job procedure, and follow electrical safety safe work practices. So referring to those 2 documents, I want to see if there's any administrative stuff that we can use to address some of these hazards that we discussed. So when you're doing that, when you're filling out the other 2, the formal hazard assessment and the site-specific hazard assessment that you're doing, refer to those documents and find, there should be some sort of, if there is an administrative control, you can do like what I did for the pinch points, because I couldn't find one. We put keep hands clear of pinch points. So I wrote in an actual safe work practice statement here that that will help control that hazard. And then the last one, admin, follow housekeeping safe work practice. So we have a safe work practice for housekeeping, and in there I think it talks about cleaning up and keeping the area clean, and that will prevent the slips and trips. So if we have water from the flow meter leaking on the floor, it will help reduce or control that hazard, or the hazard for that task. And then if we scroll down here, you can see that my document went onto another page here. I had to add another row here. So if you do need to add another row, you just right click on the table and go insert and insert rows below, and you'll see that it adds that row there. So the other thing that we can do to help shrink this onto one page is we can delete rows. So I have this row here. I'll delete the entire row. It'll shrink that up, and just put my cursor down here below the supervisor's name and press the delete key here, and that should bring it all up onto one page. So now I've got everything fitting onto one page. I also shrunk this text down already. It was font size 10 I think before, and that pushed it onto another page. You can adjust the font size if needed as well, and that'll just help bring it all onto one page, because I'd prefer it all to be on one page before you submit it. So there, this gives you an example on how to fill that out. The other document, the formal hazard assessment, looks like this, and you can see we have to risk rank all of our hazards here. And there's a little legend at the bottom down here for severity and likelihood. So you can see down there, a 1, it could make you uncomfortable, so for the severity, and 3 is up to, it could kill you or cause permanent disability today or over time. And then the likelihood, it's highly likely to happen, would be a 3, and it's unlikely to happen, or it's unlikely, is a 1. And so you can see we do perform the calculation up here, and then that tags a risk to it here. So that really helps to identify which hazard produces the highest risk, and probably the one that we should come up with the most or the best controls for, if not trying to maybe eliminate the hazard. So once again here, you can see it's the same stuff. We're probably going to have administrative and personal protective equipment for controls. And up here you can see IET 225 Lab 1 is what our job is, and put the date in there. And your task will be the one of the other two. One of them's formal and one of them is site specific. And so I'll let you choose and figure out, make sure you can identify which one requires the correct form. So good luck in the lab.